In this video, we're going to analyze arithmetic sequences. To begin with, let's define what an arithmetic sequence actually is. So it is a type of sequence where the difference in consecutive terms is the same or constant. That constant is called the common difference, and we use the letter D, or the variable D, to represent that common difference. So one of the first and most basic things that you could be asked in this lesson is, just given a sequence, can you determine whether or not it is arithmetic? So the question here is the sequence arithmetic? So let me give you a couple of examples. So if I give you a -4, 1, 6, 11, 16, etc., 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 we're going to try to find if it's arithmetic. Well, to tell whether or not a sequence is arithmetic, we have to see if from one term to the next the difference is always the same. So this is like our first term, this is our second, this is our third, this is our fourth, and they give us 5 terms. What I'm going to do is I'm going to see if I subtract consecutive terms, meaning I'm going to subtract a sub 2 from a sub 1, or I should say a 1 from a sub 2, if I get a common difference every time. So a sub 2 is 1, minus a sub 1 is minus a -4, which you guys know when you subtract a negative, it turns into a big plus. So the difference between the first terms is a 5. Now what I'm going to do is I'm going to compare the difference between the third term and its previous term, the second term. So if I subtract a sub 3, which is 6, from a sub 2, the 1, 6 minus 1 is also 5. Now just because those two happen to have the same difference of 5, you wouldn't want to just conclude it's arithmetic until we check all of them. So I'm going to subtract a sub 3, or the third term, from the fourth term. That would be 11 minus 6. That gives me 5. So far it's looking good. And then the last one I'm going to check is, what do I get when I subtract the fourth term from the fifth? That would be 16 minus 11. I still get 5. Notice how the difference is the same. That would be my common difference, D. And of course, since it's the same, we would say, yes, this is arithmetic. And the good news, in a second, I will show you if a series, or excuse me, if a sequence rather, is arithmetic. There is a nice formula you can use to get the formula for the nth term. Let's look at one more example. Let's say I give you 3, 5, 9, 15, and 23 as the first 5 terms of the sequence. Let's see if this is also arithmetic. If I do the second term minus the first term, that would be 5 minus 3 for a difference of 2. If I do the third term minus the second term, or a sub 3 minus a sub 2, that would be 9 minus 5, which is 4. Now right away, these are not the same, so I don't even bother checking the rest of these differences. As soon as the difference is not constant, I know this is not arithmetic. So that's the first thing you should be able to do, is see if the common differences are the same. If they are, we would call that an arithmetic sequence. Now, what is kind of nice is if a sequence is arithmetic, there is a rule to find the nth term for an arithmetic sequence. So the rule for an arithmetic sequence that has the following characteristics. If the first term is a sub 1, of course, that's always going to be our first term notation. So that's the first thing we need to know. And then the common difference from term to term, remember that's the d value. The common difference is d. Then the formula we can use is the following for the nth term. A sub n, the rule would be the first term a sub 1 plus n minus 1 times the difference d. This is going to be a nice formula to come in handy, and you probably could have used that yesterday when you were doing some of those rules that were arithmetic but didn't maybe realize it at the time. So let me show you an example of how we can use this formula, and I think you'll come to appreciate it. Example 2, let's write the rule. Write the rule for the nth term, and then find, let's say, the 15th term, a sub 15. Okay? We'll do two of them together. So for a, I have 4, 9, 14, 19, on and on and on. So hopefully you can kind of see the common difference is 5, right? Every time we get 5 and 5. So my d value is 5. My first term is 4. So that's all we really need to know. We're just going to plug it into the formula. So if I do, a sub n is the first term, a sub 1 is 4, plus, and then it's going to be n minus 1 times d, and in this case d is 5. Now I don't want you to leave your formula like that. It's not very pretty looking. You do want to distribute, so I'd get 4 plus 5n minus 5, and then I can add like terms here, giving me a final formula, and the best looking way of writing it I think is 5n, and then 4 minus 5 is minus 1. And if you want to check by using, first term n is 1, if you plug in a 1, it's going to be 5 minus 1, giving me a sub 1 is 4, which kind of matches what I have there. If you plug in 2, 5 times 2 is 10, 10 minus 1 is 9, that is our second term, and so on. Let's do one more. Let's say I give you 60, 52, 44, 36, etc., etc., etc. Now you might notice this one's a little bit tricky. The difference in the terms here is actually negative. I'm subtracting 8 every single time I jump a term. That is still arithmetic. The common difference, d is negative 8. My first term is 60. So to write the formula, a sub n is going to be my first term, 60, plus n minus 1 times the common difference, negative 8. So just like before, I'm going to distribute, and I'll get 60 plus negative 8, and then a negative times negative is positive 8 there. If I add the common terms and rewrite it, I'm going to have negative 8n to start, and then 60 plus 8 is plus 68. What I like to do is just double check that this makes sense. If I use n equals 1, I'll end up with, I think, a sub 1 is 60, right? Negative 8 plus 68 is 60. So that matches my first term there. And you can check when you plug in 2 that it matches 2, but I think it does. Good. So now let's go on to another example, which you can answer based on the rule that you know. Let's call this example 3. I want to write a rule for the nth term of the arithmetic sequence given a term a sub 19 equals 48, and the common difference is d equal to 3. Okay, so let's see if we can do that. To start off with, you might want to write down the rule. We know the rule is going to be a sub n is a sub 1, the first term, plus n minus 1 times that common difference d. Now, we don't know a sub n. We don't know a sub 1. What we do know is a sub 19 is 48, meaning the 19th term is 48. Or in other words, if I have a sub 19 equals 48, that means when n equals 19, I get an output of 49. So what I'm going to do is I'm going to use this formula, and instead of a sub n, I'm going to say, all right, my 19th term, or a sub 19, is going to be equal to a sub 1, which I don't know still. But instead of saying plus n minus 1, if I'm plugging in 19, my n value here is now 19, take away 1, times the common difference, which is 3. So I really have a sub 19. I know what this number is. It's 49. So I can change this into 49 equals a sub 1 plus 19 take away 1 is 18 times 3. I think you see where I'm going now. I can solve this equation for my first term, a sub 1. So I can get 49 equals a sub 1 plus 3 times 18 is 30 plus 24. I think that's 54. So we can subtract 54 from both sides, and I think we get negative 5 is a sub 1. So the rule would be a sub n is the first term, which we now know is negative 5, plus n minus 1 times 3. Now don't leave it like that. Just like the other examples, we want to distribute. So I get a sub n equals negative 5 plus 3n take away 3. So if I simplify by adding the like terms, I'm going to get 3n minus negative 3 minus 5 is minus 8. This would be the rule. And by the way, just thinking about it, I think on the previous example I forgot to evaluate, I think it asked for like the 15th term. So just to show you what that would be, and I apologize for forgetting to show you that, if I use my formula, all I have to do is plug in 15 for n. So a sub 15 would be equal to 3 times the n value is 15 minus 8. So 3 times 15 I think is 30 plus 15, that's 45. Subtract 8, that's going to be 37. So a sub 15, if I needed to know my 15th term, it is 37 in that sequence. Let's do one more example, and we'll call it quits on this video. This one's kind of the most involved, the hardest of the examples. Let's call this one example 4. And what we're going to do again is find the rule for an arithmetic sequence if I know two terms. And let's say I know that the 8th term, or a sub 8, is 21, and let's say I know the 27th term, a sub 27, is 97. So this is still the same idea. I want to get the rule, but now I know just two terms. Well, what I would do is start off by writing your rule. A sub n is going to be a sub 1 plus n take away 1 times the common difference d. Now unfortunately I don't know the a sub 1 and I don't know the common difference d. However, I do know two different coordinates or numbers of the sequence that I can substitute into the formula. If I plug in a sub 8, my 8th term, I can change the formula into a sub 8 equals a sub 1. I still don't know what the first term is. But as soon as I plug in a sub 8, I'm saying that n, the value of n, or the term I'm looking at is the 8th one, minus 1, and I still don't know the d. So I can change that into the following. Even more than that, I'm going to change what a sub 8 is. A sub 8 equals 21, so I can put 21 equals a sub 1 plus 8 minus 1, isn't that just 7? Let me just write 7d. So I have an equation here, let me kind of box it. I have an equation that's got two variables, a sub 1, the first term, and the common difference d. I can set up another equation just like it using this term. Using a sub n equals a1 plus n minus 1 times d. I know my 27th term, so a sub 27 is going to be a sub 1 plus the n value is 27 here, take away 1 times d, and a sub 27 is 97. So I'm going to plug 97 here equals a sub 1 plus 27 minus 1 is 26d. Here's another equation that's got two variables, and I need to solve for it. Well, essentially, guys, I have a system of equations here I can solve. What I would do is this. Let's rewrite this guy right underneath. 21 equals a sub 1 plus 7d. And what I'm going to do is I'm going to subtract this entire equation from the top equation. If I subtract, I'm essentially going to distribute the negative on each of these terms and then add it to the previous one. So let me rewrite what we have here. We're going to have 97 equals a1 plus 26d. And then if I distribute the negative, I get minus 21 equals negative a1 minus 7d. And when I add these together, 97 minus 21 is 76. a1 minus a1 cancel. They've eliminated one of the variables for me. And then 26 take away 7 is going to be 19d. I can solve this now for d by dividing by 19. And I think if you divide 76 by 19, you get 4. So our common difference is 4. Now that I have that, I can easily solve for a sub 1. Like I can use this equation if I wanted, or the top one, it doesn't matter which. I'm going to use this one and say 21 equals a sub 1 plus 7 times 4. So I get 21 equals a sub 1 plus 28. If I subtract 28, I get negative 7 equals my a sub 1. There's my first term, there's my common difference. Now I can say a sub n equals the first term, negative 7, plus n minus 1 times the common difference 4, distribute, get a sub n equals negative 7 plus 4n minus 4. Adding like terms, give me a sub n is 4n minus 11. There is my formula. To finish off, please try these 3 problems or a few problems for your self-quiz. Determine if in number 1 the sequence is arithmetic. For number 2, you have to write the rule for the nth term for both A, B, and C. And those are just like examples 2, 3, and 4 for those last 3. Good luck. Thanks for watching. See you tomorrow.